So today, this morning, the next session here at GroupBy is going to be Doug Bernhardt talking about the SAN primer for the DBA. So take it away, Doug.
All right, thank you, Brent. So let's get this party started, shall we? Welcome to my talk on SAN primer for the DBA. My name is Doug Bernhardt. I'm a storage engineer and product technologist at Dell, and I'm focused on SQL Server storage integration. So if you have any questions after the presentation today, feel free to reach out to me at my email address, doug.bernhardt@dell.com. So a little bit more about me. I've been working with SQL Server for about 25 years in various capacities. Started out doing development, went in to do some DBA work. I've done some architecture over the years. I've done some consulting for a few years, so dabbled in various facets. And I actually started working with SQL Server back when it was running on OS2. So for those of you who are familiar with that time frame, that's kind of a point of reference. But for the past 5 years, I've been focused on SQL Server storage and integration with arrays and that type of thing. In full disclosure, I do work for Dell, but this talk is largely based on my experience as a DBA, as well as working with storage and storage customers and the problems that they face. So while it's a vendor agnostic talk, the examples we based on Dell EMC hardware, because that's what I have hands-on experience with. So the talk is not sponsored by Dell, so the opinions in the talk are solely my own. Really what this means is that I don't have to comply with corporate media standards, and I got to pick my own slide theme and graphics, which I'm really excited about.
Which, if you haven't ever worked for a big company, is a really big deal.
Yeah. Our graphics library is like 3 things that we can show, so legal doesn't let us show anything else. And just so you know, everyone in attendance today will get their very own SAN. So it doesn't get any better than that, right? So I ran across someone that was blogging about effective meetings. And one of the key points that I loved was this concept of wait, why am I talking? So one of the reasons that I'm talking today is that storage is key to SQL Server. Anyone who has been working with SQL for any period of time, this is painfully obvious. So for those of you who are brand new, you'll one day discover that if you don't have performant, reliable storage, you're going to have issues. So to complicate matters, you typically have to rely on the SAN admin person for your storage needs who speaks a completely different language. The next reason is that SAN is a black box to most people. So before I worked at Dell, other than for a tour, I was never in the data center. I didn't have access. I had no idea what the gear was that my SQL servers were running on, what that even looked like. I couldn't find my servers in a data center, in a rack anywhere if my life depended on it. So first of all, it was cool to understand what all this stuff was and get some hands-on experience with it. But more importantly, when I started working with it, I discovered all these things that would have a huge impact on my life as a DBA that I never knew existed. Now, for DBAs, typically developers are public enemy number 1 and SAN admins are number 2. However, whether you like it or not, you depend on these people for success. So having a basic understanding of their world and how to communicate effectively with them is key to your success. So my goal in this presentation is that you learn enough to have an intelligent conversation with your SAN admin, and he doesn't look at you like this dog in the picture here. So as DBAs, we like to think that we are the alpha and the omega, the beginning and the end, the center of the universe, which everything revolves around. But in reality, there are likely many other servers in your organization and in the data center besides yours. So there's lots of other storage needs, and it's all managed by a team who has a charter to do more with less, much like you probably do. So now I kind of get into the sales pitch, which likely led your organization to purchase one of these things in the first place. So by centralizing, they're able to create a number of efficiencies. The first one of these is administration. it's a lot easier to have all the storage centralized in the data center, so admins don't have to run around looking for failed drives, updating firmware on multiple servers, upgrading capacity on individual servers, worrying about different drive types when they have to replace or expand your storage, if they have available drives and bays in your server, and that type of thing. So also the pooling and virtualization provides flexibility when it comes to capacity and performance. So if you think about how your cellular voice and data service work, you don't have dedicated infrastructure or dedicated time on a network. You're sharing a pool of resources, and the majority of the time it works out quite nicely. And we'll talk about what happens when it doesn't later on. In terms of data protection and recovery, if everything's centralized, then they don't have to worry about protecting every server. The storage is centralized, you can protect the SAN where all the data is located, and it makes it much simpler. And then from a performance standpoint, if I have a handful of SSDs, I don't have to put SSDs in every server. I don't have to choose which ones go where. I can put a handful of SSD in a SAN and boost performance to dozens of servers instead of just a couple. So, and by the way, I'm not endorsing this book here. This is just a bad attempt at humor. Okay, so now before we get into this too deep, let's talk about the top 5 things will cause a SAN administrator to flip the bozo bit on you. So when someone flips the bozo bit on you, it basically means you've been dismissed for something stupid that you've said. Now, the funny thing is about this list is that you can find guidance regarding SQL Server storage that will advocate for these things. The problem is that most of it is based on older technology, and before SSDs were a twinkle in your father's eye. So the top 5 things that will cause the admin to flip the bozo bit on you are: ask for direct attached storage, tell them you want your own SAN, tell them you need dedicated disk, demand RAID 10, and or explain that your disk queue lengths are too high. So the problem with this list is that you're basically telling them how to do their job, and nobody really likes that. So unless you want them telling you what indexes to create, let them focus on let's focus on what you should do. Okay, so you said all these things, and that I just told you not, I just told you all these things of what not to ask for, right? But you have this consultant telling you that you need these things. Now, just to clarify, I'm not talking about quality consultants like Brent and his colleagues, because surely they would never say any of these things.
Never,
but,
absolutely never. Never.
Yeah. Hopefully you're not editing materials at this point.
Note to self, bozo bit.
So, okay. So what this consultant says, if I can't get 500 SSD drives direct attached in RAID 10, my disk queue lengths will be greater than 0, and this thing will never work. So in addition, the storage admin says that I have to use this SAN thing. So before we get all worked up, let's just keep calm and find out what this SAN thing is. Because after all, education is the key to understanding. And by the way, I have no idea who these people are. I just Googled consultants and these guys showed up. So there you go.
So then I'm a little disappointed that you Googled
what is a SAN at a high level?
No, go ahead.
That I didn't. So what is a SAN at a high level? A SAN allows storage pools to be created from multiple physical storage devices, or simply disks. And then your hosts or servers connect over a network, typically Fiber Channel or iSCSI protocol. And then a SAN admin creates your volume from a storage pool that he or she has created, I should say, and maps it to a host on the server. And so then a volume shows up in your operating system, ready to be formatted and assigned a drive letter or mount point or whatever you want to do with it. So if we take a look at it from a hardware perspective, traditionally it's one or more hardware nodes operating in a cluster. And the hardware is similar to server hardware, but it's purpose-built for storage. So when I say purpose-built, it may include things like cache cards, a communication network between the nodes, specifically selected CPU, depending on the core combination and speed that works best for their software and their features. It may have additional ports and slots to provide redundancy and hot swap capabilities. So now let's talk about a couple of SAN guy terms here. So the first one is what they refer to as the front end of the unit. So each unit or node has front-end network ports, and these network ports are typically attached to a switch. There's various protocols and speeds that are supported depending on the vendor. And then the hosts or your servers attached to that same network through HBA or network cards, and they attach to the same switch or network structure. These networks can be physically separated. So a lot of organizations will have their own storage unit. They can be physically the same, but logically separated into VLANs and such, or they can be physically and logically the same. Now, on the other side of this unit is what they refer to as the back end. And when I say side, that's just kind of a virtual term. It's not referring to the physical side of the box per se. But what they call the back end is the side of the SAN where it connects to the back end disks or disk enclosures. So it used to be that these disks were in separate enclosures, but now in the newer units, they can be in the unit, the disks can be in the SAN unit themselves. And these are typically connected via SAS connections. So the hardware is built to be highly redundant, as you'll see here in a minute. So there's a lot of dual cabling, dual ports, multiple, basically everything that they can. So this is a diagram of what front-end components look like and how they're connected. Now don't panic, we're not going to have a test on how to cable one of these, but the takeaway here is that there are multiple redundant connections here for both performance and availability. So walking through the diagram, we have our server at the top that has, in this case, some fiber channel HBAs in it, and it has redundant connections to a fiber channel switch, which is then connected to a storage controllers at the bottom. So this diagram was actually taken from an 80 terabyte data warehouse fast track reference architecture that we published. And if you want to look at that paper, you can go out to dell.com/storage resources and find it there. So the backend diagram, we have, in this case, this is SAS connected on the back end. So this is the same reference architecture. And you can see that we've got a couple things going on here. So we have our SAS cables, but we also have a network connection there in the blue line that's used for the heartbeat between the controllers. So this is much like if you had a Windows cluster and you had a heartbeat running on a private network. And then we also have a couple of interesting purple lines here. So in this case, there's cache being mirrored between these two controllers over their own separate network connections. Okay, so in addition to the virtualized disk we just saw, now the virtualized storage is going virtual as well. So things are really starting to get crazy now. Some of these SANs can run as software only, so there's no purpose-built hardware. One example of that is the Dell EMC Unity VSA. So this is a virtual appliance that runs as a VMware OVA. You present virtual disks to the VM. So you create virtual disks in VMware. You present them to your VM. Those of you who are familiar with VMware, you'll know exactly what I'm talking about here. These appear as drives in Unity VSA. So every virtual disk that you create in VMware appears as a drive, and then you can create your disk pool and set up all your SAN features from there. It's fairly full featured, and it's actually available as a free community download. So if you just search for Dell EMC Unity VSA, you'll find a community edition that you can download. and run for free. Another example of this is using Windows Server 2012 and the storage spaces feature. So this allows you to basically roll your own SAN. You can present both file and block storage to servers in your network, and has some of the traditional SAN features built in. So there you go. There's your free SAN as promised. Just some assembly required.
Are there any requirements around like how beefy of a VM it needs, or any particular versions of VMware that are supported?
I believe most versions of VMware are supported. In terms of how beefy the VM is, actually so the memory is fixed in that OVA. Mm-hmm. So you can't change the amount of memory that it uses. And the community edition, I believe it's pretty restricted, because I think the maximum storage that you can provision is like 2 terabytes or something like that. So it's not, I forget exactly what the exact amount is, but it's not a tremendous amount.
Gotcha.
Okay, so here's just a list of some common SAN features that you'll find among the various vendors. And some of them have all of these, some of them just have a subset of this. But if you start to look down the list, we've got, let's see, we've got like compression here. We've got some encryption, replication, data protection features, quality of service, some caching, snapshots. Wait a minute. Some of these look a little bit familiar, right? So I think I've seen some of these somewhere before. So what does this feature list mean to me as a DBA? Well, let's ask ourselves for a minute, what happens if both the storage feature and the SQL Server feature are turned on? What happens if you both think you're in charge of data protection? And then for the features in this list that you haven't seen before, how can we take advantage of some of these? So generally, SAN features are enabled and disabled at the volume level, and you can meet with your storage admin to discuss these features. So this is the point in the presentation where you need to stop surfing the web and start paying attention. Because we're going to hold a DBA storage admin meeting. So this is where the two great titans collide, right? Mano y mano. So you both know that you can each make life difficult for each other. So this is really your opportunity to create a good working relationship. And the purpose for this meeting is we're going to discuss common areas and features to coordinate the best solution for the business by optimizing storage and database operations. Now, how's that for some management speak? That's pretty good, huh? You could feel free to rip that off and use that as your for your real meeting. So the agenda for our meeting is we're going to review the availability and recovery responsibilities, and then we're going to discuss some product features in terms of what features can you leverage you don't have today, where we have similar features or the same feature, what makes sense, and the affordability of these features. So when I talk about affordability, what I'm referring to here are things like a licensing cost. So some of these features, the licensing may be included with SQL Server, or it may not be included with the version that you're running. Same goes with the SAN. So depending on the vendor, depending on what they purchased, some of these features they may have already licensed or included in their package, and some of them they may have to pay additional for. The other thing in terms of affordability is it's good to discuss who can afford to run these features. So there's a CPU and IO cost to turning these things on. There's no free lunch, and so somebody's going to have to pay to run these features. So depending on who has the most headroom in their environment and what the benefit is, that's something that you're going to want to discuss. So some discussion points that you want to have around data protection. First of all, make sure you're coordinating your efforts. So have a discussion about who's doing the backups. Are you both doing the backups? Is your SAN administrator just backing everything up because they think that's their job? And what's the recovery strategy? So just because they're backing them up doesn't mean that they necessarily know how to recover the system or how to recover databases. You might have your own recovery strategy, be doing your own backups. And so what they're doing may not be beneficial, or it may not even be needed. So that might be a process, a responsibility that if you're doing that, and that's something that's on your plate, if you let them know, that can free up some of their resources and take some responsibility off of their plate. So the other thing to talk about is some efficiency things. So can you leverage storage-based snapshots to speed up your recovery, or use it to mount up databases in different environments? If your storage admin is taking storage-based snapshots, do they understand that both the data and log files need to be protected and at the same time? They may or may not know when they provision storage and they present it to you what you're using this storage for. Unless they explicitly tell you, usually they cannot see the files on the volumes. They just see volumes that are being used, and they see IO activity. So they don't really know what you have on there or necessarily what you're using it for. Also, do they know that they don't need to protect temp DB? So while it needs to be available, it doesn't need to be protected in terms of being able to recover from a backup. So they may be able to save some resources if they're doing replication, or they're backing up things on their side. So basically, see if you can create some credibility by being able to help them out and save them some resources. So as my kids would say, this is doing someone a solid. Okay. Data replication or availability groups may or may not be part of your data protection strategy. But it's good to talk about from a data replication standpoint. If you are doing it, who's doing it, and once again, who's responsible for this? And then which method works best? So the implementation is very different depending on if data is being replicated in SQL Server versus if it's being replicated via SAN. Now, depending on what you're doing, what your application, how your application is designed, there may be something that you can leverage here, or vice versa. So if storage replication is being used, some things that you'll want to keep in mind. Typically, the replication here is at the volume level. So as we mentioned earlier, things like keeping data and log files together, it's probably not going to be real useful if they're just replicating one of those volumes and not the other, if you have them separated. Also, let them understand that you don't need to replicate TempDB and potentially other system databases. So depending on what your recovery strategy is for recovering your servers, they may not need to do that, or they may not need to do it at as high of a frequency as they do. And then another important thing here that a lot of people overlook is if you're using storage replication, make sure your database file layout is optimized for replication. So what I mean by this is that if you have databases that you want replicated, and you also have databases that you don't want replicated, you're going to want to make sure that those are put on separate volumes. Because if you have databases that you don't necessarily care about, or you don't want them replicated, and those are residing on SAN volumes that are involved in replication, you're basically creating a bunch of noise or unnecessary replication traffic. Because it's replicating everything that's on that volume, regardless of whether you intend it to be replicated or not. So it's also a good opportunity here to take advantage of some functionality that you don't have in SQL Server. So one of the top ones that was my favorite, I guess, when I first found out about it, were the storage-based snapshots. So what they are is they're fast, efficient copies of storage, and they're pointer-based. So at a high level, it's similar to how SQL Server database snapshots work, in that you use these, and it uses we'll call it copy on write, for lack of a better term. It's not exactly done the same way, but it's similar. So that when you're accessing these volumes after you've taken a snapshot on them, then it's pointer-based operations, and there's no copy of the data involved. So it's basically a single copy of the data. You can mount them up really quickly, use them for various purposes. You can use them for recovery. A lot of vendors also allow you to integrate log backups that you may be doing in your environment today, to be able to actually do point-in-time recovery off these. But they're also really great for creating these dev and test copies of the databases, copies for research, that type of thing. So instead of having to go beg your SAN administrator for yet more space so you can back up a copy of these databases, and then go ask him again for more space when you need to restore them somewhere else, if you can simply take advantage of a storage-based snapshot, then you can do all of this and not use any additional space until you actually start writing to that database. Almost all the vendors also support some form of ESS integration. So when you take the snapshot, you can get a truly database consistent copy. Another thing that's kind of cool, and we'll take a look at this a little bit in a minute, is QoS, or quality of service. So you can set various limits in terms of bandwidth and IOPS, and some arrays also support bursting as well for dev, test, and mixed workload environments. So what this allows you to do is, from your standpoint, you can discover IO intensive code before it hits production. So this is a good opportunity to, if you work with your SAN administrator to get this enabled and get this turned on, you can help point out some performance issues before they actually hit production. And then finally, one of the things that was completely new to me is how this networking and how the volume mapping actually works. So at a previous employer, when we did releases, we would also do hardware refresh of our servers. So when our application, new version went into production, we would actually put it on a totally different physical server. So what we did, and we thought we were being smart about it, was we would set up and we would log ship these databases over, and we would get them all in sync ahead of time, because they were several terabytes, and this process would take a while. So we get it all synced up, and then we'd take a maintenance window and we would do the final cutover. So once I got to Dell and I started working with SAN technology and I started understanding this, I found out about this concept, and it's basic to how SANs work, of volume mapping. So you can take the volumes that are presented to your server, and through a simple mapping operation, you can just detach those, just like similar to how you detach a database to SQL Server, and you can attach them to another server. So when I found out about this would have saved us a tremendous amount of time and space and effort trying to get all these databases moved over when we need to do a hardware refresh or get them moved over to another server. So, all right, so let's do a quick demo.
Oh, Kyle says, I've been concerned with like doing snapshots or moving drives between one server to another because I'm worried about like a hard detach, or it seems like it's going to cause a or the storage that I'm going to attach is going to look like a blue screen of death attachment. It seems like backups using SQL are more reliable. Is that still true, or snapshots can be as reliable as SQL Server plain backups?
So they can be as reliable. You just want to take care in how you're taking those snapshots. So with SQL Server, preferably you're going to want to use a product that supports the VSS integration. That'll give you, your best chance, I guess, or not best chance, but that'll give you a reliable recovery. Now, you can also use just snapshots from the SAN provider. And here again, if your SAN admin knows exactly what you're doing, and what, if you have data and log files separated, for example, if they know what volumes those are on and those need to be treated as a set, they have a way to create a grouping of those. Here at Dell EMC, it's called a consistency group is what it's called. But you group these volumes and then they're treated as a set. So when you go to snapshot them, they're both snapshotted at the exact same point in time. And then when you do that, typically when you attach these snapshots, then SQL Server is smart enough to figure out via crash recovery, okay, I can roll forward, roll back when I need to and recover the database that way. So if you have, I don't know if with the question, if it was, they were literally getting some type of server crash when they were doing this, or
no,
okay.
he was worried that they weren't as reliable as native backups, and he says, "Thank you. That answers his question."
Okay, perfect. Okay, so now let's take a look at how we can use this quality of service feature to find out who's writing some bad queries.
Generally, me.
Before they get thrown over the wall. This is a novel concept, right? Actually catch things before they hit production. So we're this, once again, crazy talk here, right? All right, so I have a simple script here that, first of all, what I do is I clear the buffer cache, and then I'm going to capture the number of reads I have from sysdmio virtual file stats. Now, obviously, this is only going to work if you're the only one in the database and your system is very quiet. And then turn the statistics time on so I can get some time stats on this. And I have a couple of queries here. So first I'm going to do just a simple seek. And this database is one of the TPCE benchmark databases. And then I'm going to record that, the number of reads from that query. And then I'm going to run a scan query. And then I'm going to record the number of reads. Okay, so when I run this query, you can see that the first query returned in 31 milliseconds. Okay, it did 3 reads. And then the second query returned in 1700 milliseconds, but it did 1726 reads. All right, so I'm looking at this and I'm thinking to myself, that's a little bit excessive. And partially the reason why I think that's excessive is because I've seen this query and I know that it's doing a scan. So I want to make Mr. Developer a little bit more aware of the impact that he's having by doing all these reads. So I talked to my SAN admin and I say, hey, can you help me out? And can we set up, once again, help me help you. So if we turn on QoS, not only will it save some resources on your SAN, but it'll help me figure out who's writing these IO intensive queries. So here I have, this is a picture of the SAN that I'm using. And I've got a list of my volumes here that are presented to my server. And this DB SQL 1 SQL data is the volume where my data files reside. So if I edit the settings on here, there's a bunch of stuff in here. But the one that we're going to focus on for right now is there's a quality of service profile that I can apply to this volume. And you can predefine these to be whatever you want. But I've created one where instead of giving this guy access, or this person rather, I don't want to imply that guys are the only ones that write bad queries. So I'm going to put the screws to this person, and I'm going to give them the bandwidth of one spinning disk drive, a whole whopping 120 IOPS. Now, you may not want to be this cruel, but okay, so I set that on that volume. So now just for reference here, so we've got 1,726 reads on the second one. The first one is doing 3 reads. First one took 31 milliseconds, and the second one took 1,700 milliseconds. All right, now let's run this thing again. And we'll wait here for a few seconds. And a few more seconds. Okay, we're finally done. So if we go up to the top here, we'll see that this one did the same reads. The execution time is almost completely the same. So this is an efficient query. They're not pounding the storage. So therefore, query time is just fine. But if we go down and take a look at this one, now we're up to 13 seconds, same number of reads as before. So now we're getting to a point where if somebody was running this, they might stop and think, hey, this query I wrote is taking a while. What can I do to optimize this? Okay, so let's move on and talk about compression and encryption.
Also, by the way, too, you've got a bunch of you are asking questions that are unrelated, which is phenomenal. All I'm doing is I'm typing them up into a little list that I'll hit Doug with at the end. Everybody wants to ask things like, should I put my data and logs on separate volumes? You know, how do I tell my SAN admin which volumes are related? All kinds of stuff. So yeah, go ahead.
Awesome.
You keep asking those questions. You can ask them in Q&A or in Slack, but I'm just piling those up for Doug at the end.
Yeah, no, please continue to ask those questions. We should have plenty of time at the end to cover some questions. And we can talk about, we'll cover those questions. Also, if there's anything that anyone would like to see in the SAN tools or whatever that they're curious about, I can give a tour of that too, if anyone's interested. So
perfect.
Okay, so getting back to compression and encryption. Now, there's a CPU cost to encryption or compression. So where does it make sense to turn this on? In addition, the compression is implemented differently. So, in SQL Server, we know we have a couple options in terms of row and page. We have backup compression, but then also on the SAN level, depending on the vendor and how it's implemented, some of them do inline compression, some of them do post-process compression, and the algorithms are different and the efficiency ratios are different. So it's good to talk about this with your SAN admin and see what makes the most sense. The other thing to point out here is that if you can afford it, you can actually reduce your IO workload by turning on compression in SQL Server. So because all the pages are compressed and decompressed in memory, the data that's read and written from disk is in a compressed format. So therefore, it reduces the actual IO that the SAN sees. So it's important to understand here again, who's responsible for this. You can turn it on in both places. In some cases, if you're really concerned about the size of your databases, you might see additional benefit by turning it on the storage as well as turning it on in SQL Server. In some cases not. So it's really going to depend on what your data looks like, as well as how the vendor has implemented it on their side. So storage is rapidly evolving in recent years, mainly due to the flash technology in various forms. SANs are going through a major evolution actually right now, and therefore a lot of the assumptions that were previously made based on numbers, spindles, and that type of thing are no longer true, since a lot of these devices now have flash technology built into them, and so they're no longer bound by the mechanical limits of spinning drives. Storage admins, as we talked about before, so they can configure these drives into pools, and these pools can potentially contain multiple drive types. So you could have both flash storage and spinning drive storage in the same pool. The RAID levels could also be mixed in a pool. They have the ability to also assign data to a specific tier. So when they create, when they take SSD drives, they take spinning drives, they can break them out into separate tiers. They can create one tier out of them, and how this tiering works is really the special sauce that the vendors provide. So they all do it differently because it's all proprietary code that they've developed to do this. Some of it's, a lot of it's based on usage stats, but there's also other things that they can tweak to move this stuff around and pin it and that type of thing. Now, point I want to make here is that because all this is in play, so you want to pay attention to your database maintenance, and you don't necessarily want to be sloppy with your maintenance. So what I mean by doing sloppy database maintenance is just simply running a reindex wizard that sets up a reindexing job and blindly reindexes all your indexes in your database every night, regardless of whether they're ever used or accessed or fragmented. Because when you do this, you rebuild all your indexes in your database, you're rewriting all the data in the database. Hopefully, if you're following best practices and you're using clustered indexes like you should and that type of thing. So if you're not following best practices and you don't have any clustered indexes, that's a completely different talk. But another possibility here is that the performance boost that you get from your reindexing, it may be due to efficiencies within the database, or it could also be due to the fact that you've now moved that data to a different tier because you've rewritten data that otherwise doesn't get written to. So this performance boost you thought you were getting because you freshened up your indexes is quite possibly could be due to the fact that because you've now written that data, that signaled to SAN that, hey, this data is moving from a cold state to a hot state, and so I need to move it up to some faster storage. Okay, so how do you communicate? Hold on here, I got new.
How ironic is that?
just breaking it in.
How do you communicate?
Yeah, that's kind of ironic, isn't it? So, all right, let's try this again. How to communicate performance requirements. A storage admin's world is really centered around a few key metrics. Now, if you really want to talk like a SAN guy, they call this speeds and feeds. But really what it comes down to is IOPS, so the number of data, the number of trips your data takes to the storage. The storage is limited in terms of the number of IOPS it can do, but that limit is based on the block size. So your block size is how large each IO is. And as you do more work, then the maximum number of IOPS is going to decrease because the payload side is just larger. And you'll see, drives and that type of thing published and with performance stats and some crazy numbers. The problem with some of those numbers is a lot of them are published with, say, a 4K block size, which is smaller than what you'll ever be able to utilize with SQL Server. So the next one they talk about is bandwidth. So bandwidth, essentially, how much data can you fit in the pipe? And this is typically measured in megabytes per second. And it's a simple calculation of your IOPS times your block size. So that gives you your bandwidth. And then finally, one of the ones that's critical for SQL Server is latency. So basically how long the trip takes. So discuss what volumes need to be high performance versus low performance. So do your backups really need to have high performance storage? Do they really need to live on this SSD storage, or can you get away with a lower performing storage? Now, the other one interesting thing to note here is that the spinning drives, a lot of them are actually still pretty good at doing sequential write workloads. So if you are doing things like backups, you can use a pool of spinning drives for those, and a lot of times that works just fine. Whereas the newer technology, SSD technology, is actually tuned or geared more towards random I/O activity, because that's typically been the weak spot or the restriction with spinning drives. So also take a look and see, does your application hammer TempDB, or is it largely unused? TempDB can kind of be a wild card in a lot of situations. For some applications, it's critical, and for some applications, it's hardly ever used. So based on that, you can make the determination of where it should live. And then once again, don't try to dictate what RAID level or drive type that you actually need. So they probably don't tell you what indexes that you need to create in your database. Or maybe they do, I don't know. Okay, so I would suggest that you speak their language with Perfmon. The reason why that I say Perfmon is because it's common. So it's on every Windows server. It's a credible tool to use. It's one of the main tools that's suggested by Microsoft. If you work with them, or you get into troubleshooting scenarios with them, or read their papers, the main performance tool that they're going to talk about and they're going to reference is Perfmon. So everybody that knows anything about Windows is familiar with Perfmon. And then it's easy to use. So it's intuitive, it has a lot of options, logging support, et cetera, et cetera. Most of you are probably very familiar with Perfmon, but even if you have your own monitoring tools, your own DMVs, scripts you've written, et cetera, I would encourage you to verify your results with Perfmon and then communicate in those terms. Because that kind of takes, sometimes if you talk about these other tools, then the data can come into question because they've never heard of it, or they don't understand what you're looking at, and those types of things. So when you capture your data, also make sure you're collecting stats for both your peak and average times. They're going to want to know, what times a day these things are when you're recording these metrics, because you are using a shared environment, and so timing is somewhat important. So the Perfmon counters that you're going to want to capture, and these are the key ones that pretty much directly relate to the data that they're watching and the data that they're monitoring, but there's certainly other ones that are of interest. So I have the ones listed here for both block and file, if anybody actually uses that. I don't know if anybody is running SQL on SMB shares, but I'm guessing it's a very, very small minority if you are. But I've included them there for you free of charge. So On the block side, for IOPS, this is just simply the number of disk reads and writes per second under the physical disk counter. For block size, it's your average disk bytes. Bandwidth is your read and write bytes, and then latency is your average disk seconds per read and write. Okay, so you have a new BFF. You're taking long walks on the beach. You guys are hanging out after hours. You had this wonderful meeting. Life is good. So your database operations are now running smoothly. You have a bunch of new toys to play with. Your SAN admin is happy because you're not crushing his system anymore. And life is pretty good for now, until the next major event in your organization. Or maybe it's not so good and you still have performance issues. So how do we deal with performance issues? So I can't emphasize this enough, and people talk about it all the time. There's always talks, presentations done on it, but database tuning is by far the biggest bang for the buck in terms of performance and scale. I was at a previous employer, when I was hired on there, our main database server was almost on fire. So this thing was running at about 90% average CPU all day long. And they were convinced that SQL Server was to blame. We're running this toy database engine, and moving to Oracle is the only answer. Stop me if you've heard this one before, okay? So what we did was we started a database tuning effort, and there's various ways to approach this. Our way was to just start producing a top 10 offenders list in terms of queries every day, and prioritize those and start to tackle those and tune those. So within this period of about 6 months, we were able to whittle this down from an average of 90% CPU to 30% CPU, and sustain that for 2 to 3 years after that, even though the transaction rate was almost double and the storage the database size we were managing was almost double. So paying some careful attention to tuning can really pay some huge dividends. You can throw more hardware at the issue, but that tends to be expensive, and it also doesn't scale nearly as well as tuning your workload in the first place. Next, once you've done that, so if you're still having issues, then do your homework. So first of all, verify that you actually have a storage issue. There's various ways to do this, various statistics to look at, DMVs. Once again, there's talks and information published on these various tools and methods of how to do this. But make sure you verify that it's a storage issue before you actually go to the storage admin complaining about the SAN. The other sanity check you can do is to just see if you're out of bandwidth. So you can, if you don't know how to look and see what types of HBAs or what type of bandwidth you have in your server, you can just simply ask them. They can tell you, how many storage ports you're using and what the speed of those ports is. And then in Perfmon, just look and see if when you're having issues, that if the megabytes per second that are being transferred, if you're capping out on your bandwidth. So if your pipe is full, then that's an issue that needs to be addressed. But it's something that's very simple to check. And then next, if you're going to go talk to your SAN admin about your storage performance problem, make sure you can explain why you're having a problem. So don't just go to them and say, 20 milliseconds latency is too high for SQL Server. Some people can get away with that just fine. And for other applications, 3 milliseconds is way too high. So you're going to have to explain to them why SQL Server is different than other applications. Now, just like you probably don't understand the difference between a fiber channel and a SAS cable, they don't understand exactly how SQL Server works, right? That's your job. applications like Exchange, VDI, these types of things have more specific workloads. So they have more predictable I/O patterns that they're used to dealing with. They're not used to dealing with the SQL Server thing that can be quiet one day and then the next day be just totally lighting up their world. So you're going to have to walk through your issue, basically walk through it from the standpoint of, okay, when we're updating this customer, and when we update this customer, it runs these, this set of queries, and these queries do, this amount of I/O. So have the statistics to back it up, walk them through this operation, and illustrate your math. And like your math teacher said, make sure you show your work. The good news is that most SANs today are capable of massive performance and scale. So chances are that it could be just a configuration thing on their side, what tier or pool that they have allocated and put your volumes on, or that they can make a call to a vendor and say, hey, send me another 6 SSDs to throw in my SAN, and you can get a huge boost out of performance that way. Okay, create a troubleshooting plan. So work with your SAN admin to agree on a tool set and a process. The tool really doesn't matter. There's nothing magic about the I/O that SQL produces versus anything else. Just make sure that the I/O pattern that you're working with matches your workload. Another big thing here that a lot of people don't realize or they overlook is make sure your test tool doesn't write pages of zeros. So some test tools out there, when you use them to create a test file that it's going to use for the test, it just simply writes pages of zeros to that test file. The problem is that SAN vendors have gotten smart, and some of them, when they see a page of zeros come into disk, that page of zeros doesn't get saved to disk. They make a note that you wrote a page of zeros to disk. And so then when you request that page back from the storage, they just rehydrate it with zeros again and hand it back to you. So it allows them to save bandwidth on the disks, and it also allows them to save storage space this way. But the problem is that when you run a test with your test tool, the test never hits the disks, because all it's doing is hitting the SAN controller, and the SAN controller's either throwing it away or just creating a page of zeros and handing it back to you. And then also be aware of the cache in the system and the role that it plays. So if you're trying to actually test the storage itself, meaning you're trying to test how the disks are actually performing, you're going to have to use a large test file that's larger than the size of the cache in the SAN. Test the storage components and then try to reproduce the issue. So I will emphasize that this will have a performance impact on the SAN while you're doing this. So make sure you coordinate with your SAN administrator and don't just start kicking off I/O workload tests on their SAN. Maybe I need to go back and update top 6 ways to get BozoBit flipped on you. So note to self, I'll update that for the next talk.
And that's one of the questions is people are like, wait a minute, can you go back to the and then don't do this now, but can you go back to the BozoBit slide? Because I still believe some of those things and I need you to explain them to me. So
okay. Yeah, that's well, and you can find unfortunately you can find links on the internet to justify those things as well. So not sure what that means. You can find links on the internet to justify pretty much anything, I guess. Okay, so you talk to your SAN administrator and he says, what problem? I don't see anything. So you've made your case to your SAN admin, and your SAN admin, he sees nothing. So there's some possible reasons for this. So it could just be a simple matter of averages and sample rate. The tools that they run and the metrics that they collect, typically the sample rate is not very granular. So the sample rate may be only every 5 minutes or something like that, because they're not trying, they want to preserve performance on the storage, and they don't want to put a performance burden on the storage by collecting too many performance statistics or collecting them too often. The other thing is that they may be just simply looking at graphs and looking at the SAN from a high level. So there's several different levels that they can look at it from. Most vendors allow you to look at it at a tire system view and then drill down into individual servers and individual volumes. But if they're not looking at it in the right context, then your averages are not going to match up. So the blips that you're seeing on your SQL server are going to get averaged out by the other 250 servers that they have in their environment. Ask them to make sure there's no throttling or QoS restrictions in place like we saw earlier. I've actually worked with customers before where there was a network admin in the company who's no longer there, and unbeknownst to anyone, they set up QoS restrictions on one of the switches. So they were expecting 10 megabits or 100 megabits of bandwidth, and they were getting 1. So one of those kind of, is it plugged in type of things to check, but it certainly doesn't hurt to check. So the other thing to realize is that your scope is different. So your scope, when you're looking at it from a SQL Server perspective, includes many more components in the I/O path. The scope that they see when they look at it from the SAN is from the time that the I/O reaches the SAN. So even when they're looking at front-end metrics, most SANs don't know if it's a Windows host or if it's a Linux host or what kind of host it is. They're not measuring it at that level. They're just measuring the response time from the time it hits the front door of the SAN until it does whatever it needs to do. So it could be that the SAN administrator is not lying to you like you maybe think he is, but the problem is actually somewhere in between. So we looked at those diagrams before. And those are greatly simplified. There's a lot of different components in between your SQL server and the SAN. So it could be in one of your HBAs, in one of your storage network interfaces. It could be in one of the many cables that goes between your servers and the switch and the SAN, or there could be an issue inside the switch itself. Okay, so narrow it down. Remove SQL Server from the mix and use an I/O tool to reproduce the issue. When you do this, you can test a couple different ways. You can test the I/O path itself and simply see if you can fill the pipe and you can get the bandwidth that you're looking for. So to do this, you would run a large block sequential read test, say 512K or greater, and use a fairly small test file, because here we don't care about what the disks are doing. We just want to see if we can fill the pipe to the SAN, or from the SAN in this matter. And then, so that test file can be fairly small, say 1 megabyte or something like that. So once you verified that and you're getting all the bandwidth that you should be getting, now you can do an end-to-end test and you can test the disks. So here you're going to want to use a test file that's larger than the cache and run the appropriate workload in terms of the block size, the number of IOPS, and the read-write ratio that you're running in your actual SQL Server environment. So the second thing you can do, and not unless you dig too deep, a lot of people don't know about this. So there's a thing you can run called a store port trace, and this is actually done through the Perfmon tool. And there's articles online, if you look this up, that tell you how to configure it. And there's you got to watch carefully, because it's gonna talk about little endian and big endian numbers and that kind of thing. But don't be scared. The documentation's good. And so you can set up the store port trace. So what it allows you to do is it allows you to look below a lot of the components in the Windows stack. So it gets you much closer to the actual layer that is communicating with the SAN. There's also tools available to monitor your HBAs and take a closer look at what's going on with your storage drivers. The vendors have those, and you can acquire those and take a look and see, is my HBA having some type of errors? You may not know what those mean, but once you've identified that you're seeing some errors there, then you can either work with the vendor or work with your SAN admin to help figure that out. And then finally, your SAN admin can be a huge help here. So they can work with support, and most SANs come with support, or it's required, or it's very highly encouraged that they have it. They've made a big investment in these things, and so the vendors a lot of times are there with support contracts to help them out. These SAN vendors have remote monitoring capability in a lot of cases. So typically they're getting, on a regular basis, they're getting statistics on these things in terms of performance, any errors that they may have. They also have command line tools and a command line interface. So they have a lot, the SAN operating system actually has its own proprietary language. It has its own command line interface, and there's a lot of information that's available through there that even your SAN admin probably doesn't have access to. So he'll have to request some help to troubleshoot these things. But the good news is there's a wealth of information in there that the vendor can pull. So when the vendor takes a look at what's going on with your SAN, a lot of times they can tell it based on what they're seeing that you may have a bad cable in your environment. You may have a bad interface in one of your switch ports, and the switch port is going up and down, and that's causing you performance issues. So they can really be helpful here to understand what's going on in that whole path between your SAN and your server. So make sure you encourage them to leverage that resource. Okay, so what did we learn here today? Well, some basic knowledge of this thing we call a SAN helps you understand your SAN administrator's perspective. This relationship is a partnership, so it's a help me, help you type of thing. So if you can build some credibility with them, if you can do them a solid, so to speak, by giving some resources back to them, then I'm sure they'll be a lot more willing to work with you and pin all your SQL databases to SSD, just like you want. It helps to speak their language, so the metrics and things that they're looking at, anything you can do to communicate your needs in the lingo that they speak and the things that they understand will certainly help. So when issues occur, try to partner with them. Don't point fingers. Your boss doesn't like it when you point fingers. That's not cool. And then finally, encourage them to leverage their vendor support. So once again, they've made a large investment. Chances are they have it, and it's available to them. So now we're at the point to talk about questions.
There are so many. It's going to be fantastic. So Kevin says, our SAN admin standard is a 32K block size, and he refuses to change it. Is there a difference? Like, should I go to the mat fighting with him trying to get 64K?
So this may be a lingo thing. So what he may be talking about is how that data is actually written on the SAN. I'm assuming in this case that they're not dictating to you that you need to format your volumes with a 32K allocation unit. So I think you're talking about two different things. the block size that's used on the SAN is used. Typically, vendors have a certain block size that they use, and it's based on how their architecture is built and how they do rate striping and that type of thing. It really doesn't have a performance impact or performance implications like that, like the allocation unit size does when you're formatting a volume.
Yeah, totally different. Let's see here. Jamie says, I just buy my SAN administrator some chocolate to keep her happy. Yep, that'll work.
There you go.
SQL Sorcerer says, should I put my data and log files on separate volumes?
Aha. Well, so this is going to depend on what you're designing for, to some respect. So if you're trying to get max performance, and I don't know about all the vendors, but a lot of the vendors when they have a dual controller SAN, one of the controllers owns the volume. And so all the IO for that specific volume goes to either one controller or the other. So if you want to get the full bandwidth of your SAN, then you want to have at least 2 volumes, and then distribute your IO as evenly as you can across those 2 volumes. Now, so for example, when we run like benchmark tests and that type of thing, publish performance numbers, that's what we do. But keep in mind that when we do that, we pretty much have the entire SAN at our disposal, and that's the only workload running on it. So if you're doing it for max performance, that's how you'd want to design it. Now, if you're using other features, say like if you're going to use storage-based replication and performance is not as critical, you may want to put those files on the same volume to make sure that they don't get separated, because they're going to replicate at the volume level. So if you keep them together and you're getting the performance that you need, then that also will ensure that if they were to replicate those volumes or back it up or whatever they're doing from the storage side, that set is going to be kept together.
See here, Brian and PackFan asked, 2 different folks asked, so I'm dealing with VMs. Should I use VMDKs or raw device mapping?
Aha. So, I know as a SQL person, you never heard this one before, but it depends.
Yeah, right.
So the thing is that if you're going to use, and here again, it depends on your vendor, you're going to want to check. If you're going to use, for us, one of the big caveats here is that if you're going to use the storage-based snapshots and you're going to use VSS integration, so you're going to take those storage-based snapshots using one of their tools, and you're going to take it actually from the host, then that communicates a lot of time back through iSCSI. So in some of our products, we require that you have the raw device mappings, so that there's that communication channel, and it can quote unquote talk to the storage. When it's in VMDKs, you can still do it, but a lot of times the snapshot is then taken at the host level on the entire host of all the VMDKs that are in the host. So it kind of depends on how you want to work with it. If you want to work with it at the granular database level, at the volume level, or if you want to work within the host. Now, I don't know about all vendors, if that's true with all of them, but that would be one thing to look into.
Oh, throw your, while I'm at it too, jump back to the first slide, whichever one has your contact info, just because I know I'm going to end up pointing to people and saying, hey, go email Doug because he knows everything. Ronnie asks, when I turn on Perfmon, my average disk seconds per write and read are super fast. I mean, they're all within, say, 30 milliseconds. But my disk queue length is up in the thousands. And lots of people were like, hey, how come Doug didn't mention to monitor disk queue length? And while you ask that one, I'm going to go get a fresh cup of coffee because you got lucky on that. And this one will take you a minute, so go ahead.
No worries. Okay, so the problem with disk queue length is it depends on the number of resources that are actually behind it. So, you know, if you look at the analogy, so the queue length is you know, similar to if you go to the store or you go to the airport or whatever to check in, and you go up to the counter and there's a lot of people up there at the same time. Okay, so that's the queue length. But if you get through there, if you still get through there in a rather fast fashion, then it really doesn't matter. If there's a lot of, say, you know, you go to check in at the airport and there's 50 people in the queue, but there's 50 agents willing to help you, then you're going to get through rather quickly. So it doesn't really matter. What I'm trying to say is how many people are in line if there's enough resources to help them. The other thing is that just through natural activity, SQL Server, you know, and any other application for that matter, but it'll offer requests in a burst. So you'll get a huge burst and you'll see these queue lengths, you know, go up and down, and sometimes you'll see a dramatic number out of them. But really what you're concerned about, and this also kind of ties into why one of the suggested tuning methods is to tune based on wait stats, is that's really what matters. So how many resources are available to service your request, or how many requests are in the queue, really isn't relevant so long as your response times are what you expect them to be.
Let's see here. Kenneth says, is there a way to see where my data has moved on the sand? Like if we have automated tiering from slow to fast storage or fast to slow storage? Because he says, I'm thinking about end of year time is coming, let's say for reports, and I want to pre-warm up my data. Is there a way for me to like do some kind of activity on the SQL Server side and then see that my data moved up to the fast tier? I like that. It's creative.
It is creative. So yes, that information is visible, probably just not to you because you don't have the SAN tools. But I can here, let me do this. Let me switch over here real quick. Okay. So this volume here that I was working with, setting QoS statistics on. So if I look at the statistics for this volume, and this is Dell Storage Manager, so this is the management tool that your SAN admin would use if they were working with Dell Storage. Here you can see in the statistics tab that I have my tier 1 storage up here, and there's hardly anything here. And so you're thinking to yourself, okay, wait a minute there, Mr. Bernhardt, you just showed us this operation on this database that you said was pretty big. There's no storage. Well, if we scroll down here, you will see down here at the bottom, tier 3. So my data on this volume has aged, and it's moved off of tier 1. In this case, I have faster disks in tier 1, and it's down here in tier 3. Now I can also see, as you can see here on the screen, so I also have statistics on what the estimated compression ratios would be and that type of thing. So these statistics are available in the SAN. They're available at the volume level, and they're also available as system-wide level. The other thing that you might have some luck trying, and this is actually a good question because it gets into something that we didn't talk about, is that so Dell storage, we have full PowerShell integration. So you could actually write a PowerShell script. Now here again, if you have access to the tool, or if you could buy your SAN administrator chocolate or beer or whatever it takes to get the job done. But you can basically do anything with the storage, set up, tear down, view, administer, all through PowerShell. Other vendors have PowerShell APIs. Some of them have APIs through REST and that type of thing to view these statistics. But that's another option if there's certain things that, say, maybe you want to keep an eye on, but your SAN admin isn't game for just throwing you the keys to the SAN.
Let's see here. Several people asked, is there a performance difference between VMDKs and raw LUNs?
Not really, is the short answer. You know, the virtualization technologies and layers have gotten so good now, where whether it's VMware or whether it's Hyper-V, there's not a lot of overhead in there, assuming that it's properly configured. So, you know, just, I mean, if you try hard enough, you can screw up just about anything, right? So, you know, so it is possible. I know we have VMware experts here. I'm certainly not one of them, but there are different things that you can do within VMware and the settings and things like that. A lot of those are documented by VMware themselves in terms of best practices for setting these things up. But I think, you know, by and large, you're not going to see much of a performance difference. The overhead that is there, you're talking like a, you know, percentage difference of single digits for that layer.
And then, so the last one we'll do is Lee asked, he said, can you go back to the things not to say to your SAN admin slide and elaborate just a few sentences on each of those? There we go.
The bozo bit items.
Yes, yes.
Okay. So asking for direct attached storage. So if you ask for direct attached storage, you know, if you look at it from SAN admin's perspective, so they just advocated for and probably spent, let's just say, a large sum of money on the SAN device. So that's their strategy going forward. That's their architecture. If you ask them that you want direct attached storage, you better have a pretty good reason for explaining why you're so special. The other thing is that then, you know, if it's kind of like as DBAs, it's much easier from an administration standpoint if you can keep things common and have standards, right? So if you can have standard processes for managing your databases, if you can have standard processes for setting things up, one-offs create issues. So if you're asking them for, you know, essentially a one-off in their environment, that's going to create challenges for them. It's going to introduce gear into their environment that they're not familiar with, that type of thing. So asking for direct attached storage is one of those. Telling them you want your own SAN. So here again, I think in most cases, and certainly, you know, there may be some of you out there that have just a very large, very high performing SQL Server environment that would mandate just a crazy amount of storage and storage performance. But typically speaking, telling them you want your own SAN is just being kind of naive about what the performance capabilities and the capacity capabilities of these things are. So chances are, if you just communicate your requirements, they can satisfy your requirements somehow by either expanding the current capabilities that they have, or promoting you from the crappy, you know, tier 57 storage or whatever that they put you on by default to something, you know, a little better. But chances are they can accommodate with what they already have. The dedicated disk thing, you know, that goes along kind of with the direct attached storage item as well. So that presents issues with them because it's different in the environment. When you start doing dedicated disk and direct attach and that type of thing, you know, like I said earlier, that presents issues like, okay, if I set this server up and now I need to go change it later, or the databases grow, can I match the drive types that are in there? Is there actually enough physical bays in that server to support more drive types and that type of thing? Demand RAID 10, so that item is, and this goes back to kind of the days of spinning disks, and when you only had a certain number of spindles, that the advice was to use RAID 10 because it was the fastest. So it basically gave you the maximum number of spindles, say, versus RAID 5 or that type of thing, and therefore would give you the most performance. But now that we have SSD drives and we've got other flash memory technology, typically as a vendor, when we size systems, we don't have to size them for performance with crazy number of disks, because the flash technology and the SSD drives are capable of such a crazy number of IOPS in and of themselves. A lot of it now has come down to capacity because the drives are that powerful. So, so demanding RAID 10, that really just kind of displays your ignorance, if you will, of what's going on with the technology today and how the systems are designed and actually work. So then the disk queue links one, we already kind of talked about that in another question.
Yeah, and it's amazing how I see so many people still using that today as a vital performance metric, saying my disk queue lengths are high. What should I do about that? I really tell folks, think of it in terms of if you had a huge to-do list on your desk and you were executing every to-do within an hour or so, your boss would be ecstatic. He wouldn't care how many things were in your to-do list as long as you can knock them all out in an hour. Things are great.
Yeah, yeah. I mean, I kind of like to think of the analogy of, you know, when you go to the airport and you have to go to the counter to check in for a flight, right? Mm-hmm. If there's one agent, you're in trouble, right? There's a lot of people in line. Mm-hmm. But if they've got 20 people up there, you can have, you know, 40, 50 people in line, and it really doesn't matter because you're going to move through fairly quickly. So. Yeah.
And that tells us that obviously you've been taking a lot of flights lately as well. No,
I haven't. I'm just damaged by the few that I have taken.
It's bad these days. All right. Well, thanks a lot for volunteering to speak to the community this morning. Hopefully everybody gives Doug a warm round of virtual applause. Thank you so much for volunteering to spend your morning with us. Great presentation, especially I can tell by the huge number of questions and answers that came out of that. So thank you very much, sir.
Absolutely. Thank you, everyone.